Welcome everyone. In this video we are going to talk about Stewart's theorem. Let me write the name. Stewart's theorem. This theorem is about a triangle. Well, it's about any triangle actually. So let me first draw a triangle and then we will talk about what the theorem gives and then we will derive it. I don't want to state the formula because I think it will be more fun if we end up with the formula by the end of the video, rather than just knowing it from the start and then proving, which we could do, but I just want to derive it. Okay, so we're going to have a triangle. Let's name the sides as A, B, and C. And I want to name the sides. So sorry, here we named the vertices of the triangle, and now let's name the sides. I will name the side that sees the angle A, this side, as A, and the others will be in a similar fashion, will be named in a similar fashion, B and C. Okay? Let's draw them closer though. B, C. Let's say that there is a line segment that starts from A and ends at a point D, which is on the side BC. So this point is D. Okay? And let's draw this line segment. This line segment is going to have a length of X. And you probably already guessed what we're about to do, because most of the time X is the unknown and we try to solve for X. And yes, we want to express X in terms of given lengths in this triangle. And one thing that is also given is that the length between B and D is, well, we just need to give a letter name. Let's say it's, I don't know, M. This is a conventional way of writing it, I think. And let's say that the distance between D and C is N. Okay? So you can already see that A is equal to M plus N. Cool? Now, okay, so we're basically saying what is X in terms of all of these lengths. And this formula is very helpful, because this theorem is very helpful because you don't need to deal with any angles. You just focus on the lengths of the triangle, lengths of the sides of the triangle, and you're good to find X. Cool? Okay, so how can we do this? Well, to start off, there is an interesting thing that we need to first observe. If you look at this angle and this angle, let's say this one is alpha and this one is beta. We know that alpha plus beta is going to give 180 degrees. Okay. So, if I were to say, what is cosine of alpha? Well, cosine of alpha is going to be, it is just going to be cosine of 180 degrees minus beta, right? And we have a formula to find the cosine of a difference. The formula is as follows. It's going to be cosine of 180 degrees times cosine of beta plus sine of 180 degrees times sine of beta. Now, sine of 180 degrees, that's just 0, so this goes to 0. Cosine of 180 degrees is negative 1, so this is negative cosine of beta. Okay? Now, why did I mention this? What is interesting about this? Well, if we were to find two expressions, one involving cosine of alpha and the other involving cosine of beta, then we can substitute for one of them in terms of the other, and then maybe we can make some simplifications to get rid of the angles. And you might be asking, you told me that we were not interested in angles, we were not going to deal with them, and yes, by the end of the derivation, the result for X is independent of any angle. Well, it's not, well, kind of, if you were to change one of the angles in a triangle, you are probably changing one of the lengths of the sides as well, but in the final formula, we don't write it in terms of the angles, okay? So what I'm trying to say is, I mean, if you keep C and A constant, and if you change this angle, then B must also change, but we are not interested in that case. And even if there is such a change, the change in the angle could be expressed in terms of the change in the length, so we don't deal with the angles in the final equation. Anyways, this was just a side note. If that was confusing for you, just don't even bother thinking about it. Just focus on the derivation. Okay. So yes. And I mean, how can we get that expressions involving cosine of alpha and cosine of beta? We can use the law of cosines. Now, what does the law of cosines state? If you wonder that, I have a video about the law of cosines. You can access that video from the cards right now and also from the descriptions part. And also I have a proof for this identity that I used. You can also access that video from the cards and also from the descriptions part. I think it is always good to know the proofs of the formulas that you're using. That's why I named the channel Proved. It is very important that we make proofs. Okay, so yeah, let's use the law of cosines. First for the triangle ABD, and then for the triangle ADC. So first for ABD, so triangle ABD. If we use the law of cosines, we're going to see that c squared is equal to x squared plus m squared minus 2xm cosine of alpha. If we solve for cosine of alpha, it's going to be, let's see, it's going to be x squared plus m squared minus c squared over 2xm. Cool. Now, if we were to focus on the triangle ADC, and if we expressed cosine of beta this time, what is the result that we could get? Well, okay, so it's going to be b squared is equal to x squared plus n squared minus 2xn cosine of beta. And what I know is this expression is equal to negative cosine of beta. We just showed that here. So in fact, I could substitute for the cosine of beta that is here. I could substitute this expression basically. So let's do that. We're going to have x squared plus n squared. And since we are substituting for negative cosine of beta, this negative is going to be a plus. So we still have 2xn times x squared plus m squared minus c squared all over 2xm. Okay, so far so good. I hope so. And so here we could make simplifications. 2x's, they simplify. And yeah, that's about it. Also, if we were to multiply both sides by m, and when I say both sides, I am referring to this side and this side. If we multiply both of them with m, we're going to have b squared m equals x squared m plus n squared m plus, let's see, nx squared plus nm squared minus nc squared. At this point, all that is left to do is to find x squared basically. We want to group all of them together, the x squared terms. There are two in fact, so it's going to be n plus m x squared. So let's see. We are done with this term, we are done with this term, and we are going to toss all of them to the other side. So, okay, then we're going to have b squared m plus nc squared. We are done with these two terms. Then we're going to subtract negative, so we subtract negative n squared m and then let's put it here, negative nm squared, and then a plus. So we are done with these two terms as well. Cool. Now, if we were to solve for x squared, then what is x squared going to be? It's going to be, we have b squared m plus c squared n, right, this term. That is going to be divided by n plus m, and then a minus, let's say. For the other term, we have m squared plus n squared m divided by n plus m, right? And if we were to factor out this part, how could we factor it? This is going to factor as nm plus n plus m, and let's check that whether or not that factorization is correct. If you multiply nm with n, you get n squared m. Then for the second one, nm times m, that is nm squared. So yes, this factorization is in fact correct, which means then that this n plus m and this n plus m simplify. So x squared turns out to be b squared m plus c squared n divided by n plus m minus n times m. And this is in fact the final formula. This is Stewart's theorem. Notice you could have also written a here because n plus m is a, but I mean, I don't know how helpful that is, because in either case you're going to need to find n and m. It isn't enough if you only know a. We also need to know how AD is connected to BC, where it is intersecting the line B. So, okay, what I'm saying is you need to know where AD is intersecting BC. And it makes perfect sense, because if it is intersecting like this, like that, or like that, of course, the length of X is going to change. So it is very reasonable that the lengths N and M are important. We are not only interested in their sum, which is A, we are also interested in them individually. Anyways, this is it for this video. If you have any questions, please write them in the comment section. And if you want to see further videos like this, please make sure to subscribe, and I hope to see you in another video. Until then, take care.